Hello students, my name is Miss Meg
And I'm Miss Abby.
and we're speaking to you today because we are going to go over a bunch of different things about energy transfer and you're going to get to do your own experiment. To start out, Abby and I work for the Asheville Museum of Science. Hopefully you guys have visited here before, maybe post-pandemic, but we're a really awesome children's center and museum with really cool things. Miss Abby and I are STEM educators, which is an acronym, STEM. It stands for Science, Technology, Engineering, and Math. So we do a lot of different things that all involve those topics. And what we want to do is spark your imagination doing different experiments and activities that aren't as traditional as a regular classroom would be.
That's right. We do several activities at the museum, and today we're going to try and bring some of those to you over the computer. Right, and so today we're going to talk about energy, and energy can take a lot of different forms. It can be transferred in a lot of different ways, and we're going to try and break that down and understand why energy is so important and all the sort of uses we have for it in everyday life, because energy is everywhere.
Energy is the ability to work, cause motion, or change. It is found in various forms, and it's grouped by interactions of matter.
So we've talked about a lot of different types of energy today, one of them being electrical energy. And so that's what we're going to use right now to construct snap circuits. And so I have my battery pack right here, and you can see that there's little metal pieces inside that are going to connect to each other. And so they're kind of like Legos. Oops, sorry, this is backwards. They're kind of like Legos, except they have a conductive material inside. And so conductive material just means that it is able to transfer the electricity for us. So the electricity can flow through. And so we're going to start by making just a simple circuit that you guys can, will be really easy for you guys to visualize. So we'll start just locking them together. And Miss Meg, will you put on the light for us?
Yes, of course.
Great. So we've connected our batteries to our light source, and now we are going to bring it around, and we're actually going to add a switch to this underneath.
Oops.
And so as you can imagine, our switch is really just going to cut off the flow of electricity. So here we go, yeah. And now we just need one more. So this is the most critical part, right? We got to complete our circuit so that way electricity can flow through. So when we turn our light from off to on, it's kind of hard to see with the glare. There you go, you can kind of see here. Our light can turn on or off. If I have my light on, but I disconnect the circuit, the light's not going to work.
So energy is transferred from the batteries all the way through these circuits, all the way to the light and then back. We can also continue to make this as elaborate as we want. We can take apart the pieces, put them together in different ways, but as long as we have this full connection, we are going to transfer energy into a different type of energy.
Right, so we have our electrical energy that starts with the batteries, and then as it flows through, we're actually transferring that energy into light energy. So that as this light is providing light for us, it's giving off its own energy. Light energy is a really common form of energy. It's actually the type of energy that plants use. You might have heard the phrase photosynthesis. Photosynthesis is when plants are using that light energy to process their foods or to process basically carbon dioxide to form sugars and oxygen. So light energy is a really important part of transferring energy in our ecosystems. So Miss Meg now is adding in a motor. So she's adding, and you can see she's connecting the circuit again. Oh, it's going on. And here, let's slide it over so you can see it.
Go out a little bit.
Perfect. Yeah, so now our light goes on, but what do you notice about the light's energy? And again, it's kind of hard to see when the light's on, but the light is actually a little bit dimmer. And so that is because we are providing the same amount of energy as before with these batteries, but now it's powering not only the light, but their motor as well. Should that be it?
The different ways that energy interacts with its surroundings can be categorized, and we're about to go over all those different types of energy. Energy is really important because it makes up everything you do. It powers machines, it moves our bodies, it's necessary for growth, development, and change.
So as Ms. Meg has just said and just reminded us, there are many different types of energy. It comes in many different forms. And sometimes when that energy is released to power something, it can come out in different forms at the same time. So for instance, we talk a lot about heat energy is one of those forms. We have, just to cover them quick, we have heat energy, we have sound energy, we have electricity, so electric energy, and we have, what's the last one?
Light energy.
Sorry, yes, light energy, thank you. So all these different types of energy are really important, and we can find them in a lot of different places. So right behind us, actually, we have an example of a type of heat energy that our Earth actually makes. So geothermal energy is a really good example of heat energy. It's the Earth's ability to store heat and store that energy. We can actually harness that energy as scientists and use that to create electrical energy. Similarly, when we pay our power bill in the winter, when it's really, really cold and we got to heat our house, we are paying the electrical company. So they are giving us heat and we are paying that in electricity. So the transfer of energy is really important to understand because it happens all around us all the time.
Heat energy also sometimes gives off light energy at the same time. So our magma, our lava, that is giving off heat, but also the energy that it's releasing is coming off in light as well. Same as our sun. When you walk outside, it's really sunny out, you can see around you because it's giving off light, but also you can feel really warm. So a lot of times heat and light go together.
Yeah, and the sun is a really great example because as we mentioned before, the sun is the primary source of energy for our plants and things like photosynthesis. So plants are able to use that energy from the sun. So we're transferring that heat and light energy. The energy is going to go from the sun into the plant. The plant's going to, use that energy to create foods and sugars for itself, meanwhile converting CO2 into oxygen for us. And then that energy can then be transferred to us as consumers when we eat the plants. So, and then that will turn to heat energy as our body metabolizes it. And then we can use that as work. So we can use that energy that we get from our food to play sports and to jump around and do all the sorts of things our body allows us to do.
As Miss Abby just mentioned the different types of energy, she mentioned sound. So believe it or not, sound is actually a form of energy. When we speak, when we listen to something on TV, the way that sound is traveling is through energy waves. So as I speak, my voice is moving and it's traveling into your ears and hitting our eardrums. The sound wave hits your eardrum and then transfers that energy so that we can hear what people are saying.
And I actually really like that example too, because so we have those sound waves. That sound energy comes into our ear and creates kind of like that energy that's going to vibrate our eardrums and actually send that signal down our ear canal. And then it's actually transferred again from sound to mechanical to actual electricity, because our neurons actually use electricity in our body. So we are using all sorts of energy transfer all the time.
This is the part where it's your turn to make your own circuit. We provided you with the materials to be successful, and I'm about to show you what to do, how to do it, and let's see if it actually works. You are going to get a brown paper bag with all of your materials inside. When you open your bag, you're going to have 4 pipe cleaners, 2 pieces of wire, 2 rubber bands, a battery that's wrapped up in tissue paper because we didn't want it to connect to anything. We wanted to save the power. This is a small battery. Two small LED lights. You have 2 because if one doesn't work or one gets lost or broken or something, and then 2 paper clips. You're going to follow the instructions and follow along with your teacher or your classmates, and in the end, you're going to have a circuit. Now that we have our completed circuit, I'm going to explain how I did this just a little bit. So to start, we have our wires, and we have to wrap our wires around the paper clips pretty tightly. They have to be connected. So do your best, and if you're having trouble, you can ask for help. Once you do that, the other side of your wire needs to be wrapped around your LED light. So same concept. You want to be able to wrap that wire all the way around, connect it very tightly so that you have no room for error. After that's done, you should be able to take your paper clips and connect them to the battery. You're going to put one paper clip on one side and the other paper clip on the other side. At that point, your light should light up if you've done it right. If not, you can troubleshoot and try to reconnect the connections at the paper clip end and at the LED light end. But after that, to keep your LED light lit, you need to wrap the rubber band around your paper clips. So this is free flowing circuit that I can't turn on and off. If you'd like to turn it on and off, all you have to do is take out one of your paper clips. Your other one will be attached, but then you can use this side of the paper clip as a light switch. Because as soon as I take my paper clip away from the battery, the connection is broken, but as soon as I put it back on, we have a light. We actually have a little firefly flying around.
Yeah, and Meg makes a really good point about making sure that your connection between the little metal parts on the bottom of your light are really well connected to your wire, and same with the paper clips, because that's going to allow for that that continuous flow of electricity. One problem that we had when we were designing this project was we really wanted to use just pipe cleaners and not the actual wires. The reason that we had to kind of adjust our methods the reason we had to kind of adjust the methods to allow for the lights to turn on was because the pipe cleaners, although they have this same sort of wire on the inside, they're coated with all those fuzzies, right? And those fuzzies are actually plastic. And so those are what we call insulators. And so this is a really good time to talk about insulators versus conductors. So conductors are going to be like this wire. Usually they're metals, and they are able to transfer electricity. So the electrons are able to move through all the way to their source, so this light source. When it's interrupted by an insulator, like the pipe cleaners, that's cutting off the electricity, sort of like a switch. So insulators, instead of propelling the energy forward, are going to suck it in and just stop the flow of electricity. So when we talk about insulators versus conductors, we're talking about conductors as really good materials for passing electricity through, and insulators are really poor materials for passing electricity through. They'll usually prevent the flow of electricity.
Now that we've talked about the different types of energy, we're focusing on electrical energy in these next few clips. Electrical energy can be seen in a variety of forms, but what we're demonstrating right here is the electricity that's within a drone. So Miss Abby and I went outside and we flew a drone around for you to see that there is energy in this device that's causing movement that's being transferred into work. Our drone is able to fly because it is using stored energy in the battery. A battery is a device that stores chemical energy and then converts it into electrical energy. And this is a really important concept because when the battery was invented, it allowed for many different things to happen on the move. And there it goes.
Just like we saw with our snap circuits, our batteries are holding that chemical energy, and in there it has a reaction that's allowing the flow of electrons. Now remember, we need those conductive materials in order to complete that transfer of electrons. But eventually it makes it to our source, which are the motors on our drone that's really propelling it and creating that work that Miss Meg was just talking about. And as lots of us know, batteries can't live forever, right? So once they no longer have that active material and they're no longer releasing that energy, the battery is going to die, which is going to change and actually just cut off the amount of work that's being done and cause our drone to no longer fly.
Thank you guys for watching our energy video. We wish you a lot of luck with your energy transfer and your circuit building, and hopefully we can see the awesome creations you guys make. So continue learning, and hopefully you can connect with our energy.
All right, cutting off the circuit.